So here we have the situation 4x plus 2 equals 3x. Now, what I've done in the past has been, I've got variables on both sides, I need to get rid of them. Let me just take 3x's away. Now, I can do that, but if I do, notice what happens. Then I would have x plus 2 on one side and equals 0. You can go this way, but be careful. I see students move the equal sign all over the place. Right now it would be x plus 2 is 0, and then I'd need to move my units to the other side. That is a possible way to do this. What I'm going to do though, but be careful you don't move that equal sign. That's the big danger. I want to get all my variables on one side, but because I have only variables on the right, I want all my variables to go to the right. So I need to get rid of these 4x's. I can't just take away. I'm going to need to use that technique of adding the opposite. So a positive and a negative will cancel each other out. Again, have to do the same on both sides. So what have I just done? Well, I've added a negative 4x to each side of the equation. So I have my 4x plus 2 equals 3x, and I'm subtracting 4x from both sides. So that's the notation for what I've done physically. Now, each of these positive and negative x's cancels out, and they're gone. On this side, similar thing happens. A positive x and a negative x is 0, so that goes away. Positive and negative, 0. Positive and negative, 0. So what I'm left with here is 2 equals negative x. Remember, the reds are the negative. Well, I don't want to know what a negative x is. The goal is what is a positive x. So in order to switch the negative to a positive, all I have to do is turn it over. But if I've turned that tile over, I have to turn all the tiles on the other side over as well. So what we just did there was that's our division by -1, and we end with x is -2.